Hello students. So let's see the next lab experiment how to generate square wave on P1.0 continuously using polling and interrupt. So first we need to understand the difference between interrupt and polling. So consider three devices, device A, B and C. So these devices may request some service from microcontroller at any time or may provide some information to be processed. So microcontroller can handle these three devices in two different ways. One is polling, other one is interrupt. In polling method, microcontroller will check each device for any pending request. It will check device A for service request. If the request is found, it will service it. Next, it will check for device B. Next, device C. So microcontroller will keep repeating sequence of checking these devices all the time. So the drawback of polling method is that microcontroller will waste lot of time for monitoring device status. If you remember, when we generate square wave with timer using polling method, our program was continuously monitoring timer overflow flag all the time. So other way to service these devices is to use interrupt whenever some device have data available for processing or have service request. So it can send interrupt signal to the microcontroller. So at the reception of interrupt signal, microcontroller will stop all its activity and handle the request. So the interrupts are far better than polling. That is because the use of interrupt microcontroller can handle multiple tasks easily and efficiently. So let me explain the program logic for generating square wave using polling method. So in this polling method, we have to write two different routine. One is the main routine, other one is the subroutine. So in the main program, you assign a variable for P1.0 for square wave generation. Next step, you toggle P1.0 and call the timer delay subroutine for generating 1 millisecond delay using timer 1. So let me explain the logic involved in the subroutine. So in the subroutine part, the step 1, first you configure the T mode. Configure the timer mode by passing your X value into T mode register. So this will inform the microcontroller about which timer is to be used and mode is the mode of operation and operation to be used as a timer or counter. So second step, you calculate the initial value of the timer for 1 millisecond delay. So for that I am using this calculator. So this calculator is a 8051 timer calculator. You can Google the software, Google the timer software and download it for free. So according to the problem statement, we need to generate 1 millisecond time delay. So here I am selecting 1 millisecond time delay and the mode 1 16-bit timer or counter mode. So the initial value of the timer is got to 1 millisecond. So the initial value of timer HC and 66. So next step is you start the timer by setting run control bit, and the fourth step, you polling the flag bit, that is wait while the timer flag is raised. Once the timer flag is raised, you stop the timer by clearing the run control bit, and to repeat the operation go back to step 2. So this is about your polling method. The second problem statement is you have to generate a square wave on P1.0 continuously with 1 millisecond delay using interrupt method. So in this interrupt method, we have to write a interrupt service routine for timer 0. So the first two steps are similar to your polling method. But in the using interrupt method, we need to initialize the IE register. So according to the problem statement, we are using timer 0. So you have to enable the timer 0 interrupt by writing 82 into IE or make EA bit is equal to 1. Make EA bit 1 and ET1 1. So this syntax is followed for timer 0. So it's the ISR definition for timer 0. So void ISR name, that's function name, it's a user defined one, and here you have to specify the interrupt type number. For timer 0 the type number is 1. In case of timer 1 the type number is 3. So you have to include the ISR statement inside this function. According to the problem statement, you have to generate a square wave. So inside this function, you include toggle P1.0, and this format is for ISR definition for timer 1. And if the timer has to be stopped after once the interrupt has been occurred, that case the ISR should include the statement TR1 is equal to 0. If a routine return for timer interrupt has to be repeated again and again means initial value must be reloaded inside the interrupt service routine. That is, you have to reload the value once again. Thank you.